Okay, the following is a video over 2.1 notes, and this is average rates of change in the idea of limits. We've been talking about limits for a while, but I wanted to do that before we started talking about average rates of change and how they're related. So the first thing I want to do is I want to draw a graph and give you a situation and ask you a question. Okay, so on this graph, okay, I'm going to call this a position graph. Okay, it's a position graph. And I want to start off, I don't want to do that. I'm going to label this one as time in hours, and I'm going to call this distance in miles, okay? And so what I'm giving you a situation is the distance I travel, okay, the distance I travel and the time it takes me to go to work. So this is police going to work, all right? To work. All right, so at time 0, okay, I haven't traveled any distance, okay? I'm at 0 distance, okay? This is the point 0, 0. Okay, I've traveled 0 miles. I live approximately 12 miles from school, okay? And it takes me about 15 minutes or a quarter of an hour, so 0.25 hours to get there, okay? And so the question is, all right, if I'm going a distance of 12 miles and it takes me 0.25 miles to get there, the question is, how fast am I going? Okay, how fast am I going? Okay, and this is what we call average rate of change. Okay, ROC, average rate of change. And what I would do, my rate is equal to the total distance that I travel divided by the total time that I travel, okay? So if I were to say calculate the slope between these 2 points, okay, I travel a distance of 12, okay? So I travel a distance of 12 divided by, so 12 miles, okay? And this is over the course of 0.25 hours, okay? If you calculate that, my rate is 48 miles per hour. That's how fast I'm going. Okay, but remember, this is average rate of change. This is over a time interval of 0.25 hours. Okay, now, and the thing of it is, guys, is that I'm not traveling 48 miles the entire time. I don't get in my car immediately and start traveling 48 miles an hour from 0. And then once I arrive to school, immediately stop going 48 miles an hour. Okay, so what I do is, I start off and I start to do one of these, and then I shoot up as I'm on the highway, and then I get close to work. Okay, so the graph, and let me redo that. Let me do that in another color. All right. So again, I stop, I go, I stop, I go. I get on the highway and I go really, really fast, and then I get to work. Okay. And so this is the time at which I'm on the highway. Maybe it's not too much, or maybe it's not, this isn't exact, it's just an approximation. But let's say that this is, say, I don't know, 7 minutes into the trip, okay? All right, okay, so that's besides the point. We've been asking you the question, what's the slope between 2 points, for a very, very long time, okay? And we can do that given 2 points. But calculus asks the question. Calculus asks the question. And this is the big question. How fast is Mr. Police traveling? How fast is Mr. Police going 7 minutes into the trip? Okay, right about here. And given a position graph like this, what I would want to do is I would actually want to calculate the slope at this point, and we call that the tangent line, okay? And we're going to talk all the way about that. Now, what you can tell, I'm just going to erase that and draw in another line, okay? The question, and so this is a tangent line. How fast am I going on this line? Okay, and that's what we call instantaneous rate of change. So the slope of this line, slope m equals slope of the tangent line So m, and this is not what I want to do, m slope of the tangent line is equal to the instantaneous rate of change, okay? And we're going to figure out how to actually calculate the slope of a tangent line in this class, and we'll get really, really good at it, okay? But I'm concerned about what's happening at that instant. What's happening 7 minutes into the trip? Believe it or not, folks, your speedometer calculates that for you. It tells you how fast you're going at an instant, okay? Speedometer gives you your instantaneous rate of change, okay? And that's what we're going to look at, okay? The first thing we want to do is formally talk about the average rate of change, because that is something that we will need to calculate and we'll need to be good at calculating. So here's what I've got, and I'm just going to take some random function f, okay, and I'm going to plot points A and point B on that graph. Okay, I'm going to plot that point here. I have a y value of f of b, and this would be a y value of f of a. And so if I wanted to calculate the slope between these 2 points on a function, okay, this slope here, m, is equal to f of b minus f of a all over b minus a. Okay, and that's the same thing, guys, as the regular slope formula, y sub 1 minus y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so same thing. That's essentially what we're doing here. We're just kind of writing it differently. Okay, now what I want to do is I want to get started on something like this. Okay, and this is average velocity. Now remember, we were finding average speed. Okay, this was an average rate of change. Rate of change would be something like speed, velocity. Okay, those are very related. We'll talk about those in detail later. Okay, but we want to find average velocity. Okay, so it says the function s of t represents the position of an object at time t moving along a line. Suppose that s of 1 equals 84 and s of 4 equals 144. Find the average velocity of the object over the time interval of 1 to 4. So let's just graph this real quick. Let's just get something we can look at. Okay, and I've got a time value of 1 and 4, and I have a y value at 1 that is 84. Okay, I've got this point here, and then I've got at 4, I've got 144. Okay, this is not to scale, but just bear with me. And we want to calculate the slope of this line. Okay, because remember, if this is position, this is in, say, like meters per second. Okay, this is distance, this is time. And so if I wanted to find the average velocity, okay, I take the difference here, and I'm really taking s of 4 minus s of 1 over 4 minus 1. Okay, so I end up getting 144 minus 84 all over 4 minus 1, and this is going to end up giving me, I think that's 60 over 3. So this gives me 20. Okay, and that's my answer. Now, it doesn't give us any sort of units of measure, but if I'm finding, if this is position, the slope of this is a measure of, say, meters. And this is, say, a measure of seconds. So the average rate of change, the average velocity that this is traveling, is 20 meters per second. So when you take the slope of 2 points on a position function, it gives you the velocity, okay? Which is a physics term, and we'll talk more about that here in a second. I'm going to go ahead and pause the video, because we're at 9 minutes. I'm going to do 2 videos here.